Greetings everybody. I'm going to make another video about how to use a handheld calculator to calculate binomial probabilities, and I'm going to use this question as the context to show you. As a disclaimer, before I go too far into this, I have to say I don't recommend using a handheld calculator, even like a nice graphing calculator, to do binomial probabilities like you see here, because it's just so much typing. The formulas are complicated, and it's a lot of typing. So, but I mean, you can do it, and what I'm going to show you is just applicable to some calculators. It's hard to make one video that applies to every calculator or app for your phone or whatever that might be out there, but let's just say I recommend StatCrunch. StatCrunch is included with my math lab. I have videos on how to use StatCrunch, but we can use a calculator, so here goes. So in this question, this is a binomial experiment. We're going to ask people if they have confidence in newspapers or not, okay? Some question along those lines. And the data we have is 46% have very little confidence in newspapers, and the other 54% don't feel that way. Okay, so you either feel like this, that you have very little confidence in newspapers, or you don't. Okay, 46% versus 54%. 46% to have very little confidence, 54% to feel otherwise. So we're going to select 10 people at random and ask them how they feel, and they're going to be like yes or no, according to this question about confidence in newspapers. Okay, and when we ask 10 people how they feel, any assortment of yeses and nos could show up. Maybe they're all yes, maybe they're all no, maybe some mixture. Okay, but here's what we want. Okay, suppose that with the information given, right, blah blah blah, this first part A here says, what's the probability that exactly 5 people out of the 10 say they have very little confidence in newspapers? So let's start there. So as I said, this is a binomial experiment, and the variables that we use for binomial experience is P, that's the probability of success, or saying yes or whatever. In a binomial experiment, there's just 2 possibilities, right? We ask people how they feel, and they either have little confidence in newspapers or they don't. Okay, so P is the probability that they say they have very little confidence in newspapers. Q is the probability that they don't feel that way. Okay, so P and Q have to add to 1, all right, because those are the only 2 outcomes that are possible, but those were the numbers that were given. Okay, and then N is the number of trials. Okay, so we're going to ask 10 people how they feel about this. Okay, and so N is 10. Now, the probability that X people say yes to this question about having very little confidence in newspapers is n factorial over n minus x factorial times p to the x power times q to the n minus x power. So that's our formula to calculate the odds that X people out of the 10 say yes to this question about having very little confidence in newspapers. Okay, in our case, like, we know N is 10, so I put 10 in everywhere, and we know that P is 0.46, so I put 0.46, and Q is 0.54. Okay, so I get it set up like that. Now, I can answer this first question of, well, what are the odds that exactly 5 out of the 10 say that they have very little confidence in newspapers? Then I just have to put 5 for X, right? So I do like this, and there you see it, and I get 0.238. Now, I'm making this video about calculator use. So I have this calculator, and this is a very common type of calculator. It's hard for me to show you with the camera setup I have how to do this. So I'll show you what it looks like, okay? All right, now first of all, this exclamation point that is used in this formula is called a factorial. So in order to find out how to do that on your calculator, you may have to do a search, okay? So like, for example, here are 2 calculator interfaces. On this one, if I was going to find the factorial function, I would look under this math key. So I would do second or shift, and then I'd press that to activate math, and it would be under probability. Okay, and on this calculator, it would, if I press this key, PRB for probability, I would find it under there. But it's different. Like my point is, like, it's different every time. Like, you know, for different calculators. All right. So let's say that, like, somehow we figure that out. Then I need to type this in. Now here's how that should look, though. Okay. All right. So here is a common calculator interface. You see this right here? With this calculator here, or, you know, just about any graphing calculator, I can type things in so they look like this, and that's what I need to do. Okay, so with the fraction key, the division, I can create this fraction, and I do 10 factorial, 5 factorial times 5 factorial, and then I just, with parentheses in my exponent key, I type it in just the way you see it, and if it looks like that, it's going to be okay. All right, here's the formula written out, and I want to type everything in so it looks like that. All right, and you could even put parentheses around these if you wanted to. It's not going to make a difference, but, you know, if you did, then fine, same thing, right? See, there it is. There's our answer, 0.238. So the bottom line is, I have to know where the functions are. I have to know how to access the factorial key, and that might vary depending on what kind of calculator you have. And otherwise, I need to type this whole fraction so that it looks like it's one fraction by itself, and then times these other things with the exponents. Okay. All right, so that's the way I have to do it. So there's two things that have to happen. I have to know where all the keys are. I have to know where the factorial key is. I have to know how to type in exponents. I have to know how to type in a fraction. And then I type it in with the numbers that I have. So that's what I would do for this first one. So that's part A, right? Now in parts B and C, here's the way I would do it. Those are interpreted as, what are the odds that 6 or more, same thing as at least 6, of the 10 say yes to the question? And what's the probability that less than 4 or 3 or less? Okay, so to do those, I might think of it like this. I have to use the addition rule. So the probability of at least 6. So think of that. Here's the addition rule that we would use for something like that. The addition rule says the probability of event A or B happening is the probability of event A plus the probability of event B, given that if A and B can't both happen at the same time. Okay, so we would do something with addition like this. Like, so say the probability of at least 6 of the 10 saying yes is the probability of 6 saying yes, or it could be 7, or it could be 8, or it could be 9, or it could be 10. Okay, so that's how we would do things for at least 6. Now, in order to do this any further, I'd have to, like, calculate this formula with a 6 in it, and then add 7, and then add 8, and so on. Okay, now I'm gonna leave that to you. The answer you should get is 0.283. Okay, now this last one I will do. That's the probability that less than 4 of the 10 say yes. So, okay, what would that look like? How could it play out that you ask 10 people this question, and less than 4 say they have very little confidence in newspaper? Well, it might be that none of them said that. That's one way less than 4 can happen. Or, same thing with the ors here, that amounts to addition. 1 or 2 or 3. Okay, so now what I'm going to do, okay, is I'm going to evaluate this formula with a 0 for the x, with a 1, with a 2, and with a 3, and you see all this. So I'd have to, like I was saying in part B here, I'd have to work each of these out and add them together, and that is, I mean, that's hard to do. Like, if you're just gonna, if all you can do on your calculator is type these numbers into that formula, that's a lot to type in, but it can be done. Okay, so here first concept, well, we have to add the probability of 0 through 3. Second, I write out the formula, which you see here. Third, this is what it looks like. Okay, all right, so see, All right, I typed it in, and this is an online calculator, right? But I wanted to show you what it should look like on your interface for whatever calculator you're using. So I typed in like with the 10 factorial, 10, 0, 4, 6, 0, 4. I typed all that in, and then I just put plus, and I continued, okay, until I had all of them. It's no different than that one we did here. It's just that I'll do the first one, and I'm not gonna evaluate that answer. I'm gonna put plus. I'm gonna put the second one in, and plus, and put the third one in, plus, and put the fourth one, and then get all of them, and then press enter, and then it gives me 0.245. Okay. All right. So 0.245. That's what we're looking for. All right. That's the answer. Probability less than 4. Okay. So that's how you can go about doing it on a scientific calculator in general. I still recommend using StatCrunch, but I'll leave that up to you. And from here, I think that you can probably make it look right. You make it look like this when it goes into your calculator in the interface on the display, right? The only other real issue I see coming up is where to find that factorial key.